guys, if you find this video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, in this video our focus will be on domain, range and graphing of sine x and sine inverse x. So let's find out the domain and range of sine x and cos x with the help of unit circle with radius 1, which is intersecting with x and y axes at 1 0 0 1 minus 1 0 and 0 minus 1. So let's first take the function fx is equals to cos x. So as we can see, x could be any real number. So the domain for cos x is any real x. So domain will be minus infinity to plus infinity. And now for the range, the value of cos x depending on the point on the circle can go to a maximum of 1 at x is equals to 0 degree and a minimum of minus 1 at x is equals to pi. So the range of cos x is from minus 1 to 1. Now for the function fx is equals to sine x could be any real number. So the domain of this function will be from minus infinity to plus infinity. And for the range, the value of sine x depending on the point on the circle can go a maximum of 1 at x is equals to pi by 2 and a minimum of minus 1 at x is equals to minus pi by 2. Therefore, the range of this function is from minus 1 to plus 1. So domain for both cos x and sin x is minus infinity to plus infinity, whereas range for both is minus 1 to plus 1. Now let's look at their graphs, where blue graph is for cos x and orange one is for sin x. So in a last video, we learned that a function has an inverse only if it is 1-to-1 or geometrically if its graph passes the horizontal line test. But as we can see here, these trigonometric functions do not satisfy these conditions, and horizontal line test does not hold for both cos x and sin x. So they do not have inverse, but it is possible to reduce the domain of such functions that is not 1-to-1 in such a way that an inverse function can be defined. So if we can reduce its domain so that between that range function is invertible, that is it passes the horizontal line test, then we can define its inverse function. So now let's reduce or restrict the domain of cos x to 0 and pi. So if we just take this curve segment of cos x, then within this interval the graph passes the horizontal line test. Similarly, we can restrict the domain of sine function to minus pi by 2 to pi by 2 so that it is 1-to-1 and it passes the horizontal line test. So between minus pi by 2 and pi by 2, this curve segment will pass the horizontal line test. So as we already know that the domain of sine x is minus infinity to plus infinity and its range is minus 1 to 1. So for the domain and range for sine inverse x, we reverse the order by switching x with y So here range of sin x will be the domain of sine inverse x, and the range will be the reduced domain of sin x, that is minus pi by 2 to pi by 2. So the reduced domain of sin x will be the range for sine inverse x, that is minus pi by 2 to pi by 2. So to find the domain and range for inverse function, we just switch x and y, so that range of sin x will be the domain of sine inverse x, and the reduced domain of sin x will be the range for sine inverse x. So for fx is equals to sine inverse x, range is from minus pi by 2 to pi by 2, which is called the principal value branch, or just simply the principal value. So when we refer to the function sine inverse x, we take it as a function whose domain is between minus 1 and 1, and range is from minus pi by 2 to plus pi by 2. Now for the graph of sine x and sine inverse x, let's first graph sine x. And if we draw a reflection of this graph in the line y is equals to x by restricting the range of values of the reflected curve, then we will get the curve for or graph for sine inverse x. So we just draw the reflection of sine x to get the graph for sine inverse x. So this blue curve represents sine inverse x, whereas this yellow one is for sine x. And this line y is equals to x is the line of reflection for the restricted range of values of the reflected curve. So for fx is equals to sine x, domain is minus infinity to plus infinity, and its range or y or fx is between minus 1 and 1. And now for the function fx is equals to sine inverse x. This distance is the same as the height of this curve, and that is 1. So this will be 1, 2. So from 0 to 1 here, and similarly this will be 1, 2. So it will give us minus 1. So the domain of sine inverse x will be minus 1 to 1. And the range, that is y or fx, will be from minus pi by 2 to pi by 2. Because in this range the function will be 1 to 1, and it will pass the horizontal line test too. So the range will be minus pi by 2 to plus pi by 2. And this range from minus pi by 2 to plus pi by 2 is called the principal value or principal value branch. So in principal value branch, we just reverse the order by switching x with y to achieve an inverse sine function. So here in fx is equals to sine x, restricted domain is minus pi by 2 to plus pi by 2, whereas range is minus 1 to 1. So to achieve inverse of this function, we just switch the role of x and y. So now here domain will be between minus 1 and 1, and range will be between minus pi by 2 to pi by 2. So by switching x with y, we will get an inverse sine function whose domain is the range of sine x, and range is the restricted domain of sine x. So similarly, we can find out the domain and range for other trigonometric functions too.